All right, so this is where we were. Okay, so we had, all right. Hi everyone. So today we are going to continue from where we had left. And we had left at the last topic in Scala. The topic was the case classes. All right. And case classes are just like regular Scala classes, just that they are immutable by default, meaning you cannot change the values of the parameters individually. You can create them once and use them. All the parameters have only get methods on them, not the set methods. That's what it means by immutable by default. These are quite useful classes, and in case of Java, it was a common pattern to create such classes. Now, since it was very frequently required to create such classes which are immutable by default, and quickly we should be able to create those. Therefore, Scala basically added this as a core construct. Now, so the case classes are immutable by default, can be done pattern matched. Okay, so what does it mean by can be pattern matched? So there is something called there's something called case condition in case of Scala, and those we will discuss during the one of the sessions. So there we will basically try to match an object with a particular class. Okay, so that's called pattern matching with respect to the objects. Now, the case classes, the compiler automatically generates hash code and equals method. So you don't have to create your methods of hash code and equals, right? Those who are coming from any programming background like C++ or Java or other languages like C#, they would have noticed that when you create a class and you want to put the objects of that class into hash table, you need to have a method called hash code on that class, right? So instead of you typing it, case classes automatically generate hash code method. And it also has equals method. So there is very less boilerplate code because as a tradition in case of Java and other languages, we end up typing these functions, these methods. In case of case classes, it's quite convenient to have these methods automatically generated. All right. Okay. So also it basically helps you write more expressive code, because when you look at somebody's code and you see that, okay, there is hash code method, equals method, it looks very uh, unfriendly. Also, the more code you have, the more errors it will have, and the less maintainable the code will be. So the equals method is sorry, the more of the boilerplate code you have, these are called generally the boilerplate code, which means that these methods and these functions are like chores that you have to do it as while defining classes. All right. So all right, so we have created an example here. Let me just open that up. All right, so you can see in this folder you have, if you want to take a look at it, I'll just share with you. Okay, so you have these two classes here. Okay, so let me zoom out a bit. Now here you can see that there are two classes. One is called email, other is SMS. It's so simple to create such class that you don't have to define in multiple lines. And here when you are defining a class here, you're passing two variables to it. You see that? Okay. So what will happen is this will basically create a constructor which takes two arguments, as well as it would create the get methods on these so that you can access these variables, but read only access, not the modifiable access, as well as it'll have all other boilerplate code automatically generated. Okay. Also, a case class can extend a class like notification, right? You can define the case class just like this, or with the right, it can extend other classes. Here it is extending a class called notification. Okay. Here, this abstract class notification does nothing. It has no variables at all. And we just have used it to show you another example. All right. So what we are doing here is we have created these two case classes. I'm going to use the um, lab. All right. Now let me just open my terminal. Here I am opening, say, Jupyter. All right. And since Jupyter takes just Jupyter's Scala version takes just too much of memory. Last time the problem that was happening. Let me just try to see if I could log in here. All right. Sure. I'll explain to you, Bintao and Sachin, in a minute. All right. Great. Now let me just open a terminal. We could also open the new, and we could open the Scala version here, but I'll just keep it really, really short and simple. Okay. So here we're defining, or let me just show you in the notebook itself, and then we'll show you. I'll stop my kernel. Okay. Because this, when we are starting the Apache Tori, it's starting the Scala as well as Spark both in the background. Okay. So, all right. So here, where was my notebook? There was a notebook somewhere, right? We had big data folder. Inside big data, we had Scala, and inside Scala, we had 7 April session. I'll just continue from there. All right. I'll just stop this one. All right. So let me just start from where we left. Okay. Now, inside the here, you can see that there is something called abstract class here. What is abstract class? Abstract class is a class without any method, or sometimes it does have methods, but this is a class which cannot be instantiated. You can only create another class by extending this kind abstract class. You can create another classes by extending the abstract class, but you cannot create an instance of notification. The way we are creating an instance of SMS, the way we are creating the instance of email, we cannot create an instance of the abstract class. All right. While you can create an instance of the the case class. Now, what's the difference between normal class and the case class? Case classes are basically normal classes, just that this is a shorthand and all these variables become read-only. All of these variables become read-only. I'm going to show you what it means by read-only. So let's say we are just taking this code and putting it here. Okay. So here it says that when we have started the two classes, SMS this and this, essentially it created the equals method in these, which compares all the variables of the class with another class. In the usual class, you will have to write In the usual class, you will have to write these methods to compare two objects, but in the case class, it has done the job by itself for you. Okay, so it's comparing this and this, it's comparing this and this, and so on, and then it's saying that they are equal. All right, if you change the second method, so let's say we are taking this here and we are instantiating here. Okay, so these are our classes, and let's say we just add one more exclamation, then these will not be equal. Okay, so now it has not printed anything. We could actually say print ln they are not equal, right? So all right, this is correct only, right? All right. All right, so am I making a typing mistake somewhere? This is correct only, right? Let me just type it again. This is correct only, right? This is why it is like this. Okay. So here, this particular condition is not being executed correctly. Let me just see why. This is correct only, right? Okay, because this actually worked earlier. We had done this earlier. Okay, and this actually worked fine. What? Okay, so there was some strange character here. And if I just keep it in the same line, then it gives the result. All right, this is actually very strange. Okay, so it's a strange thing that else has to be in this line, and this syntax I have never known before. Though I've written good enough code in Scala, but this error I've never faced. Okay, so my understanding from this error was that if I bring else to the same line, then it basically does not throw error. Only then it works. Okay, this is little awkward. Okay, All right. So now the one that I wanted to show you was the important part. The important part was that we were creating these classes, and here we can also put these in a hash table. We can also create a hash map and use that to say we are saying mm, where map equals map, right? And we could say map, or we could just say here first first SMS, okay, first SMS, and let's say this is value, right? So the thing I wanted to demonstrate is that usually when we are putting our objects into a map, we need to implement hash code method. Okay, this shows that hash code method is implemented automatically. Okay, and this shows that equals method. Okay, let me take a step back and explain from the beginning. All right, some of you are finding it strange that what does it mean by abstract class or something, and why do we need an abstract class? Okay, so Scala, just like any other programming language, provides you object-oriented way of doing things. When you do object-oriented way, meaning you can create these composite data types or complex data types called classes. Just like struct in C, you have classes in Java, C++, and Scala and C# and other languages. You have a concept called class. Class is like data type, like integer, like string. So those are classes, right? Those are basically the data type, and you can customize those data types for creating your own. Now, when you are creating the data types, you usually find uh, convenient to have a parent class, and like, for example, animal, right? So usually animal is an abstract class. Why? Because there is no particular entity which we call an animal, right? There is either dog, cat, people, a person, or something like that. There is no instance of animal as such, right? So such classes are called abstract class. Why? They exist not because they will have some instances, but because there is a common behavior of all the creatures which we call animal, like they live and so on, right? So for example, if we have to create, say, a case class called dog, it would extend an animal. All right, so that's how we look at it. So similarly, there could be a cat and so on. Also, another important part to remember is that if we are abstract class could have something called abstract methods that you need to implement while implementing a particular class. Okay, why? Let's say animal has certain behavior which every animal does it in different ways, so every animal will have to implement it in different way. Okay, yes, the sole purpose of an abstract class is to be later inherited in another class. Good, good. And so like the way when we are saying our variable x is of integer type, in the same way, we could say our particular Tommy is a dog. All right. So that way we can instantiate as many dogs, as many cat as we want. In the similar way, we have an abstract class called notification There could be all kinds of notifications, email notifications, SMS notifications, and so on. Therefore, notification is an abstract class. So if we need a generic notification which we want other people to implement, then we generally create that as abstract class. And here we are creating two kinds of notifications. One is email, other is SMS. So we are creating a complex data type called email. Data type essentially means a class. Class is like a blueprint. Okay, class is like something that is like a type of something, right? So here email extends notification. Okay, and so on. So I hope this is clear to you now. A question is, yes, thank you, Hitendra. Yes, abstract class provides template. Question from Alok, by default, all classes extend object class in Java? Yes. In Scala, is there, is the any class which is, so yes. So actually the class is any, the one that is at the top, okay? So that's a default class which is implemented by all, okay? So next question from Bintao is Bintao's next question is, can I say abstract is a collection class? No. So abstract is a generic class. Collection basically is other class. They're basically an example of abstract classes, collect various collections, and so on. Okay. So all right. So essentially, abstract class is something like, let's say we want to say animal, right? Animal has certain behavior. So we can extend animals' behavior as dog and cat and so on, right? So animal does not have any method as such. We are only saying that dog is extending animal, meaning dog is a concrete class of an animal. Okay, so that way. Our question is, a case class is a short example of abstract class? No. So the case class is an inline example of normal class. So case class is a short example of a normal class. Okay. Right. So if we try to, so let's see if we can. All right. So you can see that here we have defined this abstract class. If you try to create an instance of the notification, it says not found. So it says notification is not found. Why? Because that's an abstract class, right? That's an abstract class, and good. So was able to explain Bintao and Sachin and Alok? Yes. Okay. A question from Robin is that starting from abstract class notification, how do we save the codes shown on the screen right now so we can reuse it later? Okay. So actually you can just go to this particular URL. Okay. It's available there. You can use it from there. Also, here that you see this one, I'm anyway going to commit it. I'm going to anyway commit it, and you can find it again in the GitHub repository. Okay, in this folder you will be able to find it. Okay, this is the file that I'm going to put it in, and it'll be made available to you. All right. Good. Great set of questions. Now, another question is, was I able to answer your question, Robin? A question from Binta is, how about singleton object? Good question, Binta. So what all concepts we have? We have concept of abstract class. Then we have concept of, let me see if I could put it down, normal class. Then we have object. Then we have, with respect to object orientedness, the things that we have discussed so far, we discussed the case classes, right? Okay, so these are the things that we have learned. Now, a question from Binta is that what does it mean by singleton object? So abstract class, let me again go from one to one. First of all, in this hierarchy, we will put class in the top, right? That's how we learn things. Then we learn something about object, and then abstract class, and so on, right? So this one that you see, the case class, the normal class, is nothing but composite or complex data type, right? The way we have int, the way we have string to represent the primitive values, we could create our own class, right? Our own data type, right? Our own data type, which we can instantiate, okay? Which we can create object of. We can create as many objects of any class as we want. Like here, as you see, first SMS is an object of SMS. Okay, first SMS is an object of SMS. And second SMS is another object. And this way, we can create as many objects as we want for any class. All right, so that is what is called as the objects and the classes. Now there is a special keyword called object. This object keyword helps you create a singleton class. What does it mean by singleton? It means that you don't need, there can be only one instance of this class, and that's the only instance you will be using. There is no other instance. You cannot create more than one instance, and the default instance is what is given to you. It is equivalent of static class in Java, but don't worry about the analogies. Here, singleton class is single object of the class. So if you want to have just one class having only one object, if you just want to have a class which can only have one object, then mark it as object rather than a class, right? All right. Now, another thing is abstract class. Sometimes we don't want people to instantiate our classes, mean we don't want people to create object of these classes. We want people to mandatorily implement these classes or extend these classes, so that we can say that, okay, if you want to do something, you have to implement these methods. So let's say we are defining our model, or our function which takes something as argument. We could always define an abstract class as the argument, and then anybody who is implementing those abstract class can be passed as an argument. So we can kind of define contract by defining abstract class. We say that, hey, if you want to be honored by us, you need to implement this particular class, right? The way we have like serializer class, right? It is mandatory to implement serializer in order to get something done. So abstract class, the role of abstract class is that it exists so that other people can implement. It cannot be instantiated, cannot be created objects of. Okay, we cannot create objects of this class, cannot create, it looks like strange English, cannot create object of such classes. Okay, case classes are nothing but normal classes. It's a shortcut to define classes with read-only variables, right? So this is what it is. So here we have defined the case class called SMS and email, and these are our objects, right? So let me show you what it means. Okay, so you can see here it is showing that this is an SMS. I can access any of these variables. All right, I can access, say, what is that variable? Message. Okay, so but I cannot change this message. Okay, you see that? We cannot change the message. So all the variables of this case class are read-only. Okay, case class are read-only. So let me just show you if there is something called case class. Okay, it's not here. We can actually define our class X, and we can have a variable. Okay, so I think we discussed the class, right? My class is not a member of. Okay, or let me just show you this other way. This is correct only, right? This is correct only. Let me just. All right. It takes me a while to get into the Scala zone. Okay. So actually I had created a couple of complex projects here. So this is one. You can see, extend this. Okay, let me just try to do the same thing probably. So this was correct actually, right? My name is, okay. All right, so just created a class. Actually, the variable name was supposed to be initialized. And here we are basically creating an instance of this class. Okay, so let's just. All right. So also please note that to instantiate a class, either we have to use a new keyword. Case classes can be instantiated without the new keyword. All right. Now we can say access the name method here. You can see name variable here, and we can also assign, say, value to it. And now this value changed and we can access it. So what I wanted to show you is that when we try to change variables of the case class, then we have to uh, we have to define our normal, like a normal class. Here, in case we are trying to change the case class variables, we cannot, because all these variables are read-only by default. Okay. So I hope this gives you a clear idea that here we are defining a class called my class, in which there is a variable that we have defined here and set some value to it. Okay. And then we are instantiating it and assigning it, trying to assign some value to it. It is successful. Okay. But the same thing was not successful in case of our case class, because are all these variables are read only. All right. So I hope that gives you a clarity on what does it mean by read only. Question from Binta is, there is a new keyword before the object. Why does not first SMS has it there? That's a good question. So yes, so in case of normal classes, we need a new keyword, but in case of case classes, we don't need a new keyword. All right. All right. Next question is from Mohammed. Abstract class in Java is, that's right. Question from Sachin is, when we say where n, it's taking a reference of notification. Yes, we were trying to define n equals where n equals, say, new notification, or say notification normally, and it was throwing an error saying class notification is abstract, cannot be instantiated, right? So that means that essentially means that we cannot instantiate an abstract class. All right. I hope these error messages are making sense to you now.
Sandeep, it means we can take the reference, because in upper example you have seen where n is equal to notification.
Right. That one, that syntax was wrong. Okay. So if we are defining a case class, then we can call it like this, but we can't call right here. It says it is completely different. It says the notification is not found. Okay. So for normal classes, the way we define an object is using new, while in case of case class, we can just define it like this. Okay, I'll show you here. This is a better example like this. So you can say where something equal, where name of the object equals this. All right. Uh, Sorry, I have unmuted somebody. Okay. Yeah, sorry, I have unmuted admin. Okay, this is good. This is good. So, all right, any more questions, or should we move ahead? I hope I was able to answer your questions. Great, great set of questions. These questions are important. So we learned about these constructs of the case class, the scalar. There is one more concept that might come to you again when we discuss about the about something called pattern matching. So I think I'll just cover that idea. Those concepts we'll just cover. There is something called pattern magic matching in Scala. Let me just try to give you a brief, and right, let's see. A question from Binta is, can I use where to define SMS instead of well? Of course. Of course, it is up to you. We can use well or where, it is up to us. Okay. So here, if we are saying, let's say here, let's say these two lines, we can definitely use it like where. Okay. We can definitely use it like where. All right. That means that we can modify these again. So we could modify these. All right. So yeah. But if you are defining it like val, then we cannot modify it. Okay, it'll say we are trying to assign to val. All right, so that is the difference between val and var. Great. Now moving ahead. Now there is something called, before we wrap up. All right, before we wrap up, let's just talk about pattern matching. Okay. So also we can actually run these classes by running using Scala case class.scala or pattern matching.scala, right? And also we can run the same thing in the notebook, as well as we can do the same thing using the interactive console, which is Scala normal. Now let's take a look at what does it mean by pattern matching. Okay, so let's say we defined abstract class called notification, right? And we have defined there is a method called show notification. Okay, so let us say that we are building a system in which we want others to implement our notification system. So we might define this in our class, that there is something called notification, and we have defined as part of the system that we will show the notification. Okay, so here, all right, so here it is saying that the notification, okay, is ambiguous. Import instance notification, I think. Okay, let me just try to define it in a separate one. Okay, so first of all, we defined a class called notification, and then we are defining here show notification, and let me just refresh this. Oh, I did not save it. All right, I'll just walk you through the code. By the time it refreshes, it is going to take a bit of time. All right, so what we are doing is we have, let's say, abstract class called notification, and we have defined a method called show notification. So whatever argument you pass to it, what it is going to do is it's going to call this method. Okay, and there we are saying that notification match, as in if this object is of type email or SMS, it does these, it executes these parts of logic. Okay, so in case of Java, it was a very big problem that we always have to compare the data types of various objects. Now you can see that there is a case match and case kind of a syntax. Notice that this keyword and this keyword is identical, but they have absolutely different meaning. So we are saying match this object with the particular class, and in case that happens, then convert it into the email object, and then you can access those variables using the arguments that we are passing here. Just like we say try catch in case of Java, in the similar way here we have any object and we are matching with various classes. So it's a common pattern in many works that we write a generic method which takes a object of say abstract class, and then inside it we can match and take a conditional work. We can do some conditional work based on what it is doing. Okay, a question from Shravanti is that in this, can't we access the values of values by first SMS.sms? We can access like SMS has two methods, two variables. One is called from number and message. So you can access these variables. Okay, and the previous example, yes. All right, let me just show you a previous example. Where was the previous example? I think towards the end. Okay, so towards the end there was this simple example where we had, yeah. So we were defining, say, right, from and masses, correct? So we could access those variables easily. We could say first dot masses like this. All right, we can definitely access it like that, as well as we could. All right. So what was the number, right? From number. Okay, so we can definitely do that. Now, coming back to the example that we're taking, which is a extension of the previous one, here what we are saying is we have written a generic method which can handle all kinds of objects which are extending notification, right? So you can pass either the objects of email or SMS to show notification, and then inside it, here this is a very interesting construct which is called pattern matching in classes. Okay, it sounds like a switch case statement in C, but it is very much different from that. Here we are matching the data type. Here we are saying that in case the notification is of type email, okay, or SMS, then do this. Okay, just like the try-catch blocks or the object matchings in other languages. So you can use the case construct to match the data type of various objects. All right, so this is what you do in case of Scala. Okay, so greater than equal. So this is basically part of the syntax. So yeah. So first you write object, whatever argument you're passing here, name of the variable, name of the variable for the argument, then match, then curly brackets, followed by case, followed by the name of the class and its arguments. And then here, after the equal and greater than, we have this the condition or any construct. Okay, so any piece of logic we could write either like this, could write the statements and so on. So it is basically matching the object types. All right, I hope this is clear. So there are two things we talked about. One is case class, other is case and match pattern. All right, should we start? Should we go ahead? I hope this is clear to everyone. So this was basically an example of pattern matching and case class. A question from Sachin is that how is it similar to pattern matching? Also, I have not yet executed this, so I'll just execute it. Okay, so first we are, let's say, defining things and then we are calling things. Okay, and then we are executing. So you can see here we are showing notification with some SMS. Similarly, we could also create instance of the email, right? We can also create an instance of email. We could say some email, and we could write from, let's say, from at CloudxLab, and here, hello, right? That's the subject line. Okay, and then we could just call notification, call show notification on this object. Okay, so you can see that here it is saying you got an, oh sorry, I did not type the name here correctly. So, all right, you got an email from Sandeep at CloudxLab with subject hello. Okay, now question is, how is it similar to the try catch? Okay, this is only for the people who are from Java background. I'll just say catch X, then do something, catch Y, then do something, right? So yeah, so what happens is here, when this block throws some error, then whatever error it is throwing, first that error data type will be matched with this catch, then this catch, this variable which we are passing, and then if whichever catch is matching, then that particular one will be executed. So that's why I was saying that it looks like a catch, because we are basically going through object by object and comparing that and executing the parts. All right. All right. So yes. All right. So this was an example which I was talking about Java. So yes, we have try catch same as that one in here, and we can again use the um, basically similar construct like try catch finally in Scala also. All right. Good, good. So this was a brief introduction to Scala. Whatever we have learned so far, we can utilize that. We will be utilizing that in learning Scala, is Spark. Right. So that was a brief introduction on Scala, and we'll be going ahead with Spark. So we are going to more focus on Spark as compared to the Scala part. All right. Okay. So let's start. Should we? Great, wonderful. So far, what we have learned is just the basics of Big Data Spark. We have just gone through one Hello World example, as well as what we have learned is basics of Scala, which are sufficient for learning Spark. And so now we're going to understand the basic constructs of Spark, and we will try to solve problems with these basic constructs, and then we'll move on to the advanced constructs. We're going to focus a lot on RDD. Why? Because that is the fundamental or foundation of the distributed computing, and we must be aware of how does it look like, and how does it matter, and how do we convert our problems into into Spark in the form of RDDs. All right, we must know that, because under the hood everything is an RDD in case of Spark. All right, so now, so what exactly is the RDD? RDD is the basic construct in Spark. Construct as in, that is the fundamental thing that they have implemented. So RDD is collection of data elements. Just like in normal programming, you have arrays, right? You have in SQL, you have tables, and you have data frames in R, collections in MongoDB. Similarly, Spark provides you something called RDD. RDD is construct against which you'll be programming, right? So it has three words, RDD. So it is a distributed data set and which is resilient. So distributed means that the parts of the RDD will be running on multiple machines, while for you, RDD will look like it's a array. It's a humongous array, which is humongous array of objects, which is distributed on many machines and resilient. Resilient in the sense that in case one of the machines dies, it can still work by running the same part on another machine. Okay, let me share the slides. All those slides would be available as part of the, sorry, let me just share the slides with you. Okay. Okay, so RDD is basically a class in Scala written by Spark guys. Okay, so Spark is a open source project which is written in Scala. So if you and the objective of the Spark project was that we should be able to do distributed programming. Okay, so for that they constructed the first thing called RDD. RDD is nothing but resilient distributed dataset. It recovers from failures. It is um, so this RDD class looks like your standard Scala collections, just like you have array. Similarly, there is an RDD. It's a kind of a data structure, but under the hood, when you operate on it, then it gets work done using many computers. All right. So, so basically, the RDD, the data structure RDD, or the class called RDD, in case of Spark, is essentially under the hood a whole idea in which it has partitions. It's basically collections of elements which has partitions. So, and each partition is like this. So one partition could be on one machine, another partition could be on another machine, and third partition could be on another machine, and so on. Right? So RDD is made up of partitions, and these partitions could move around in the network. All right, these partitions could be in the memory, could be on the disk, or could be really lazy. So RDD essentially is a class which represents a data structure which is distributed in the network and is also lazy. We'll talk about lazy soon. When we operate on RDD, internally you are operating on individual partitions. These partitions will be executed by something called Spark applications on multiple machines. Okay, so one Spark application processing this partition, another Spark application processing this partition on this particular node, and so on. So this is how the RDD looks like. And this RDD has 15 elements from 1 to 15, and it has, yeah, 1 to 15 elements. The node 3 has uh, 4 elements. Which one is missing? Right. So node 4 has only 3 elements. So when we process this RDD, when we do some kind of computation, what it means is we're going to run our code against this data inside this application. Okay, so RDD is basically a resilient distributed dataset in which the parts of it are processed or processed on multiple machines. Now, question is that what will be running inside this? Here, our application, our logic will be running. So we'll write our program will be taken to all the machines, and on each machines, it will be processing one partition at a time. So you can visualize it like this. So RDD is essentially making the distributed computing possible. Now, if you write a for loop which is iterating from here to here, that kind of logic is not acceptable by Spark. Therefore, when we are writing this Spark application, we'll be writing using certain constructs that are provided by RDD instead of just normal looping around on the array, right? So we'll be learning those parts, that how do we structure our programming logic so that it can be distributed on multiple machines by Spark to be executed against every partition, every partition. Okay. A question from Raju is partition of RDD can be compared to a block in data node? You can actually compare it, yeah, kind of you can compare that one. So, but here it's basically a logical representation, and you will find the difference as we go ahead. All right. Okay. So we kind of will learn that part. All right. A question from Sachin is, so do you mean RDD is executed by Spark application? So whatever program you are going to run or write, let's say what you want to do is you want to count the total number of elements on every partition, right? Or let's say we want to multiply every number in an RDD by 2. So that program, that logic will be run here. That Spark application is nothing but your application running inside over here. And this will be executed against this particular data. This Spark application would see this data. All right. So we learn this part, that how do we structure our logic so that it can be a valid Spark application. Right? And then there is something called a driver, which which actually launches things on the cluster and which also accumulates and gives you the output. So when we are doing PySpark and we are launching this Spark shell, what is happening is we are launching a driver. Okay, so driver is that entry point which distributes and collects. All right, like the main method of your program is the driver. Okay, so question from Bharti Raja is that what basis partition number will be fine? Is it based on number of nodes? Good question, good question. So we will learn that part. So very short, I'll try to answer. One, we can specify by ourselves that we want these many partitions. Second, if we are reading the data from HDFS, then the number of partitions are generally equal to number of blocks. Third, if we are loading data in the memory, then number of partitions are equal to the number of default partitions are equal to the number of CPU cores available. If we are launching our Spark application on top of Yarn, then and loading in the memory, then the partitions are total number of partitions are a function of how many total cores are available across the cluster. So in short, the number of partitions are defined optimally, cleverly by Spark by default, but you can override it. You can control the number of partitions. And that's how we generally control the distributability of our application. As in, that's how we control the parallelism. If we have 500 machines and we want to run our work on 500 parallelly, then we will create 500 partitions. So that's how we make our work parallelizable by the way of changing the partition. That's how we make our work executed in parallel by enforcing the number of partitions. Although if we don't specify number of partitions, the Spark will decide the partitions by itself. Okay. All right. So a question from Sachin is, can you again repeat what is the relationship between RDD and Spark application? Spark application processes data and RDD represents data. Okay, so Spark application processes data, or Spark application runs your Spark application is nothing but your code which is going to process data, and while RDD is an abstraction over the data. All right. So this is one partition. This is called a partition: partition 1, partition 2, partition 3, and partition 4. So these are the various partitions of the data. All right. So it's a logical partition. It's a logical partition, and it's not physical partition, but generally this logical partition is based on a physical partition. Okay, if you are creating an RDD on top of, if you're creating an RDD of an HDFS file, the number of partitions in that RDD are going to be equal to the number of blocks in the HDFS by default. Okay, so a question from Sachin is, so it can be done by Docker. So that's a complete different argument. Here, you can always think of RDD just like another data structure, which maps the RDD, which maps the RDD to actual objects. So Docker is like a complete process inside which you can run a Spark and so on. If that is your question, that can Docker does can Spark run inside Docker? Yes, definitely.
I mean, Docker can do partition also, correct? Who does the partition?
What is the partition in Docker?
Logical partition, who do? ADFS.
No, so here we are not talking about the storage as such partition.
Okay.
Partition is a concept which RDD came up with. Spark came up with RDD, and the way they define is RDD is a huge array in which they define their own something called partitions. Partitions is decided by Spark by default, based on various resources available, based on what kind of data you are trying to load, and so on. Based on that, Spark defines RDD having certain partitions. All right.
So I mean that partition of disk. It is a partition of disk. For example, if you have a 500 GB disk, so
Right, right, right.
partition will be done by Spark.
So this partition is different. Okay.
Okay.
So in case of RDD, it's a partition of not of disk, partition defined by RDD. It's like saying that I have my bookshelf and it has 5 partitions. In the same way, Spark is saying that we have RDD and RDD has partitions. And these partitions, Spark is going to decide in the beginning, but we can control it. And you will get to know about it more. So when we are creating an RDD, we can create an RDD using either another RDD or using a data source. We can create an RDD out of a file or out of an in-memory array. So we can convert an in-memory array into an RDD, or we can load the data from a file into an RDD, or we can create another RDD from one RDD. All right. So somebody is unmuted. You want to say something, Subbu? All right. A question from Bintao is, can RDD contains from data from different type platforms such as, yes, so you can create an RDD out of all kinds of sources. All right. You can create an RDD from your R, you can create a data from in-memory array, you can create an RDD from tables and so on, right? So the only difference with respect to RDD is RDD does not have columns, it only has rows. Okay, it doesn't have columns. As compare, if you compare it with table, you can think of RDD as a big array of objects. All right, so great. Now, so it's an immutable distributed collection of objects split in partitions, which may be on multiple machines or multiple nodes, can contain any data type, but it can contain a data type of from Python, Java, Scala, or including your own classes. Okay, so So RDD is a huge array of objects which are which can be distributed by the way of partitions, and each of these objects could be the RDD could be made out of any of these kind of objects. Also, sometimes let's say RDD can be kept in the memory. By default, RDD is lazy and it is in the disk, but you can also create an in-memory RDD, right? RDD provides you caching into memory and be retained in the memory while we access it during the life of the application. So RDDs can auto recover from the node failures. Okay, can have any data type but has a special data type for key value. Okay, so it has kind of a special preferences and special methods for key value kind of data types. And it supports two types of operations. One is called transformation and other is called action. All right, so we can define an RDD. We can define an RDD, and once we define an RDD, we can only call the methods provided by the RDD on your data. Now, those methods are generally classified into two buckets. One is called transformation and other is called an action. So we will talk about creating RDD after the break. Should we take a break for 10 minutes? Break for 10 minutes. All right. A question from Sachin is, so Spark does the processing also and partitioning? That's right. Partitioning is only a logical partitioning. It's like mapping that, okay, these blocks of data will be on one machine, this block of data will be on another, and that's basically partitioning. That's what is the definition of partitioning of Spark. As we go ahead, as we do more hands-on, we will get the hang of RDD and partitions, and also what does it mean by Spark applications. These are the three things we will understand as we do more hands-on. All right. So let's go ahead. The first thing that we need to do is we need to learn how to create a partition. Okay, so the easiest one is using the sc.txt file. Using sc.txt file, we can create a partition. I'm going to use Spark Shell. All right, I'm going to use Spark Shell instead of I'm going to commit this file, right? I'm going to just save it, checkpoint, and then how do I commit? I'll go to the big data folder, go to Scala folder, and say git commit, and message is classwork. Okay, and it has classes, etc. That's my message, and I'm committing the class. Okay, so whatever work we have done, we're going to commit it. And once we commit in case of Git, after committing, we'll have to do push. We'll have to say git push. Now it is pushing my local repository changes to the GitHub's repository. Okay, so Git manages a local repository and so on. All right, I'm going to go with the console like this. I hope that's okay. And yeah, now here we have something called Spark Shell, right? So, oh, you mean the git commit? All right. So git commit, and this one was git commit, and then followed by git push is what I did. All right. So this is what I did. Now I'm launching Spark Shell. By default, if I say Spark Shell, it'll launch the default version. For now, we are okay with the default version. And later on, we will go with Spark 2 version. All right. Then we'll use /user/ Spark version, and then bin / Spark Shell. Okay. The way I showed. All right. Okay, so it is starting up. So this command you need to execute in your own directory, in our own checkout. Okay. So the way you generally do is you have to first create a Git repository on say GitHub or any other place. Then you do Git clone. You get a local copy, and then you start working with that. And once you're done, you do the Git push. Okay.
Hi Sandeep, this is Alok.
Yes, Alok.
Yeah, just I want to I have doubt on that RDD partition.
Okay.
Actually, I try to understand like how does it work. Like,
Hmm.
so we have like one RDD, a big RDD, and
Right.
we give it like a three partition or four partition into that.
That's right.
So it is like a logical partition we are doing for the give for getting the parallelism for the execution.
Right, right. It's basically that logical. So what this Spark is doing is that it's saying that, okay, this file looks like big file. So let me just create multiple partitions for it. Okay. And these partitions will be nothing but mapping between the elements from 0 to 20 will be on this machine, 21 to will be on this machine, and so on. So partitioning, RDD is basically kind of mapping between actual data and the in-memory one.
Okay, so like the file is exist in HDFS,
Yeah.
and we are launching that Spark job, and
Right.
in the three machines. So we are
Uh,
giving the three partition.
right.
So all the three jobs will read that file into from the HDFS,
That's right.
and according to the partition that from 0 to 100, it
Right.
will process into one machine, and 100 to 200 it will process second machine,
Correct.
and 200 to 300 it will process into third machine.
Correct.
So
Correct.
that not all the whole file will be processed into one machine. It
That's right.
will be getting distributed, and it is giving the like three part of the file is simultaneously executing.
That's right.
Yeah, okay, okay, okay.
Okay.
Thank you.
That's right. Great. Great. So basically, I'll describe to you in a couple of diagram. What I'll suggest is that we do a little hands-on, and then things would make more sense. I'll explain what's going on, and then we'll do detailed analysis. All right. You will get it by the time of it. So the idea that I'm trying to do is that instead of a theoretical knowledge, because what happens is that if we don't do hands-on, it always becomes like a elephant in a room kind of a scenario where um, different words mean different things to all of us, right? So that's why instead of only the theoretical part, I want to actually take all of you to the hands-on, and there I'll describe what it means by individual parts. All right, so be with me. So Spark Shell is the command with which we are going to launch Spark. Okay, ignore the first error. Looks like some package errors. No worries. And the error that you see above are basically for launching the Spark UI. It is trying to launch the Spark UI. Whenever you launch the Spark Shell, it launches the Spark UI. It also connects to, say, Hive and others. So that way. So Spark Shell is nothing but Scala shell. When you run Spark Shell, it is going to launch Scala under the hood. Okay, just that there will be extra objects like SC and SQL context. Those are the extra objects that you will find. Okay, now coming back to it. So here, all right. So here we are saying that where lines. Okay, here we are saying that where lines. Okay, this is the file that we are going to load. Okay, we are going to load these files here. Sorry, this is the file, a single file that we are going to load as RDD. Now, what it did, this sc.text file, sc is Spark context. This is the driver. This is so this here this is our entry point, SE. And the entry point has a method called text file. What it does is it creates an RDD out of a text file. This is our text file located in HDFS. By default, the way we have configured Spark Shell, it is trying to load data from HDFS. All right, so let me just show you what it means by this file. If you go to, say, file browser, and there you go to this particular data, this particular folder, right? Okay, so this is the file that you will find. So this is the file that we have loaded as plain text. Now, this sc.text file, this method that you see, what it does is it creates an RDD which is mapping to this particular file, and essentially when we run the Spark, when we run the RDD further, what it'll do is it'll create those partitions based on how big this file is. Also, lines is going to contain an array, a big array of lines from this file. Okay, this lines is an RDD. This lines RDD is nothing but an array of the lines from this file. So first element is going to be, say, this whole thing. Second element is going to be this. Third element is going to be this. Fourth element is going to be empty. Fifth element is going to be this. So when we are creating the RDD using sc.text file, it creates an RDD of strings. RDD of strings means it's like an array of strings. Each element of this array is going to be one string. Okay, it's going to be one string. Now let me show you this part. Okay, so did I execute? Yeah, lines. Now to take a look at what is lines. So when we run lines command, it's returning the data type of this lines. The data type of this line is RDD. You see, org.apache.spark. This is the package name from here to here. And this is the name of the class. And this is the data type of the elements of this class. Okay, so this RDD contains an array of strings, right? Now, here further, this one basically is the base class. We can say abstract class. And this is the particular extension of that class. Okay, just like we had SMS extending the notification. Similarly, map partitioned RDD is extending the base class. So this is how it is. All right. Now, if you want to take a look at this, we'll have to say call a method called take. We can't really say lines and give me first element, right? So when we do take, you see, the moment we said take one, it gave you one element. You see, it gave you one element. Basically, the take returns you an array of elements. Okay, so when I say take 5, it gave me the first 5 lines of the RDD. Okay, these are the first how. And if you take a look at this string, if we assign it to a local variable, we say well first 5 lines equals this. Okay, so we got first 5 lines assigned here in this local variable, right? And if we say length, right? So the length of this first 5 lines is actually 5. Okay, so basically when we say take, then it brings those many elements from remote to your local machine. Okay, so in this statement, you see this one is an RDD, this one is an RDD, and this one is your local variable. All right, and if you see, This one is an RDD in SC.txt file, lines is an RDD, and this string is a local string that you're passing. Okay. A question is, can R be used? Can R be used in Spark except Scala and Python? Yes, R can be used in Spark. You can say Spark R. There is if you go to bin folder, there you will find Spark R. Then you can launch that. Okay. Okay. Which part of sc.txt file splits the lines? Basically, the sc.txt file is creating an RDD which is made up of lines. Okay. All right. So what kind of error are we getting, David? Do you want me to take a look at the screen? Because the chances are if you're getting errors, others will also get the errors. Okay. Did you execute this particular content, this particular code earlier? Did you create RDD earlier? Okay. I've already put that in chat. Okay. So I put that in chat. Now you can try. If you want, I can take a look at your screen and could help you. So all right. So this way, okay, question was this, right? You can try this. All right. A question from Binta was that how to start R with the Spark in Jupyter Notebook. All right, that I need to experiment with. That I have not yet figured out. All right, we were trying to create more Jupyter Notebook, our custom kernel, but that has not worked out well yet. Okay. All right, great, great. So is anybody stuck? Do you need help? So what we learned was these two things. One is creating an RDD, and other is using the take to get those many elements from the RDD. All right. A question from Mohammed is that does it inherently split on /n? /n as in number of machines? Oh, the opposite slash. Opposite slash, just like C and Java. All right. So yes, by default, sc.txt file splits data based on new line. And in case there is no line in this file, if you delete all the /n characters from the file, it will only be loaded as a single element in the RDD. Okay. If this file, if you just remove all the /n from the file, then what will happen is this RDD that we have created will be having only one element. Okay, will be having only one element, and instead of these many elements. Right now, how many elements does it have? We can generally use count. We can generally use count. You can see it has 128,000 elements right now. Okay. Is that what you wanted, David? Should I just copy paste everything? All right. This is the work from last time. All right, great, great. So we were able to create an RDD out of the we were able to create an RDD out of the HDFS file. Okay. Now, let's say your data is not in HDFS file. Instead, it is in the memory. Imagine that we have this particular line, this particular array. Okay. So ARR is a local array of Scala. So ARR, the one that we have just created, it's a local range. All right. It's an in-memory data. Now we can convert this into an RDD by using a method called parallelize. Parallelize takes an in-memory array and convert that into an RDD. All right, it converts that into an in-memory RDD. Do I need to increase the font? Okay, so here this nums, if you take a look at nums is basically an RDD, but it's a different class. It's called parallel collection RDD, which is inheriting the base of the RDD. Okay, so nums is an RDD, but it is loaded from the memory. So though all of these methods have the same kind of, all of these variables like nums and lines are RDD, but they are different classes. Abstract class is same, the way we had notifications earlier. The abstract class is RDD, which they are inheriting, and while the parallel collection is essentially the actual class. A question from Raju is, can we see the storage of these arrays or partitions? So storage of this one is in memory. Lines was an RDD. It is still pointing to the HDFS file, so it's not really keeping anything in the memory. Okay, so it doesn't have a separate location. All right, if you want to take a look at the number of partition, you can generally say, I'll show you. So lines dot, I think it is, okay, yeah. So using partitions, you could generally take a look. So it says, it shows you that it is going to be an Hadoop partition. Okay, so it has two partitions. All right. Etan's question is that please share the code for this. Actually, you could also use this one. Okay, you could use from the PPT, and I hope that I'm not okay. Let me also share what extra lines I'm doing. Okay, and I will follow the advice of David and will show you this. So this is what we just did. Okay, this is what we just did. Okay. All right, so here we basically created a local array of element from 1 to 10,000, then converted that array into an RDD using parallelize. So parallelize is the most important function here. So parallelize and text file converts an HDFS or any other file, any other text file into an RDD, while parallelize converts an in-memory array into an RDD. To know about partitions, we can always use this method. We can always use the partitions variable, and we can call partitions dot length to get the partitions. Okay. All right. So I copied from here to here, right? Okay, so yes. So previous history I copied from here to here and then. All right, great, great. Now moving ahead and all right. So we were able to load the data from HDFS and from the memory into an RDD. All right. So this was the word count. We have already done it. So we are going to move ahead. We will do it, come back to it later. All right. Now, we were talking about two kinds of operations. One is called transformation. One class of operations is called transformations and other is called action, right? So there are many transformations provided by Spark, just like Scala, just like we have collections in Scala, we have one extra collection called RDD from Spark. Just you can always think of RDD like another collection, just that it's a distributed collection. Okay, so just like a data structure, you can think of RDD. Okay, now so transformations are operations on RDD. The transformations generally create a new RDD. The examples of transformation is map and filter. Map and filter. So, okay, so basically we can use the functions like map and filter to operate on RDD. There are many functions like map and filter. We will talk about those like flatMap and so on. We will talk about those as we go ahead. So there are many operations that are provided on this data structure, or you can say collection, which is a distributed collection called RDD, and we're going to write many transformations on top of it. So the transformation is run against every partition parallelly in the cluster, and you get the new result. So transformation generally creates another RDD. Transformation generally creates another RDD, and let's take a look at this further. So imagine that we have a function called multiply by 2, and we have, let's say, a RDD of numbers, and we want to multiply every element by 2. Okay, so what we have to do is we have to define a function like multiply by 2 and call that via map function. So map transformation is nothing but it runs provided argument. Whatever argument you provide to map transformation, that is supposed to be a function. So you pass a function to the map transformation, and that function is run against every element of the RDD. And it creates a new RDD from the results of execution of the function. All right. So let's take a look. Imagine that we have an in-memory array of 10,000 elements. We converted that into, this is an in-memory array of Scala. This is a standard array of Scala. And we parallelized it, meaning we converted that into an RDD, right? Array is a data structure. Array is a data structure in Scala, right? And nums is an RDD here, which is basically a kind of a data structure provided by Spark. Now, let's say we want to multiply every element on this in this RDD called nums. So we define a function called multiply by 2, and then we call this function just to test whether it's working or not, and then it seems to be working. So then we basically run this function against the RDD. All right, let me just show you what I'm talking about. So first of all, let me give you this. Okay, remove the output examples. Okay, now let me start from the top. So first of all, we are defining a local array ARR. ARR is just another variable. Okay, which we have defined as Scala. Then we created the RDD called nums. We created RDD called nums. So nums is basically an RDD which is created by the way of parallelizing an in-memory array. And then we are defining this function which basically multiplies by 2. So it's just our function, just like the standard Scala function. Okay, like this, right? So anything you pass to it, it'll be multiplying by 2. Now we can call this function just like we called this function on standard Scala collection. In the same way, we can call this function using map over an RDD. Now, this is a very, very important aspect. So here what happened was, this is our RDD, and this was our function. Okay, this was our code. This was our Spark application, which contains some logic. So we handed over this via map to RDD and say that, okay, please execute it against every element of our RDD. And this would give us new RDD, just like Scala collections. And there, if you take a look at this, okay, it has given us the double of every value. Okay, so now you might argue that, can we use a for loop over our Scala RDD? Can't we just use a for loop? Then if you use a for loop, that means that you will have to bring the entire data to an individual machine and then do it. Here, what's happening is we are taking code to the data. So we are handing over our function to Spark and saying that, hey, can you execute it, please? And Spark is taking that and executing it, right? Though it doesn't give you as much control, it does not give you as much control as the for function would give, for loop will give, but it would make it possible to write a program which can be easily distributed. Now, here you're saying that please run this function against every element of nums. Now, it is none of your concern that it is run using 100 threads, it is run on multiple computers, it is run on 20 PCs or 20 GPUs or 20 CPUs. It is none of your concern. As long as your function multiplied by 2 gets executed against every element of the RDD, you are happy, right? That's why this kind of code is distributable, meaning this kind of code is parallelizable, meaning that you can write this code without knowing how many computers are going to be, whether it's going to run on one computer or 100 computers. Your program will run flawlessly. All right? Your program will run flawlessly. Okay, so am I making sense here? No, I have not given to all of you. All of you, please, when you are messaging me, please give a public message unless it's really required to send a private message. Because the moment you send a private message to me, suddenly by default, everything changes to private. And then whenever I'm sending the message, what happens is it goes to only that person who has sent me the private message. Okay, so I prefer it's okay to if there are something really critical, then you send it private. Okay, otherwise it's okay to let the team know. All right, so All right, because otherwise I'd have to read it again, as well as I have to change my settings back to everyone. Okay, in the chat, you have to select send it to everyone. Okay, now, all right, is it working for all? Is this code clear? All right, this is just like Scala. Okay, just like usual Scala, and here this map function, there is a difference between. Okay, I just want to show you this part. So I could also have local doubles, and we could say, okay, so here is the difference. Do you notice the difference? You see, we wrote this logic multiplied by 2, and the same thing could be executed using default Scala, the local one. And here, in the same way, it's executed on Spark. So this function called map is executed by Spark, while this function is executed by local machine using Scala. Okay, so a question from Sachin is that why we need map here. What we are trying to do is we are trying to multiply every element of this RDD by 2. One way could have been that we loop over this RDD and then increase by 2, correct? But then that would end up bringing the data from the RDD to the local machine, right? Therefore, we must not do that. Instead, we should operate on the RDD by the way of transformations such as map. Okay. So it's not that this map is not like key value map. This map is basically equivalent of running a for loop on all elements. In a for loop, we are taking each element and running this function against it. Okay. All right. Uh, did I make sense? So this is not that this is not that map collection. It is that map, the higher order function. Okay. This is an higher order function from Scala. All right. Raju, did I make sense? So this map basically, this diagram shows you very clearly. Imagine that we have a RDD like this. It has 1, 2, 3, 4, and we want to run this function against every element. So we say map this RDD.map, and we pass this argument. We'll get this result. Okay. A question from Binta is, does RDD only work in Hadoop platform? Not really. RDD can work on any kind of platform. Spark can run on Hadoop. Spark can run independently, and Spark can also run on systems like Amazon and Mesos. So it can run everywhere. All right. Even if you don't have Hadoop, you can just download Spark and run it locally on your machine. All right. So that was the map transformation. Now moving ahead. Okay, so we just studied map just like Scala. So here in Spark also there's a higher order function like that. We call that transformation. Next kind of transformation in Spark is filter, right? Exactly like Scala, all we have to give the filter is a function that qualifies an element to be filtered or not. Okay, to be that if the function returns true, the element is retained. Otherwise, the element is dropped. That's what the filter does. So here, let's say we want to just retain the even numbers. Okay, even numbers. Then all we have to do is we have to define a function called isEven. Okay, and pass say 5 to it, and call this even function on our RDD. Okay, so here we go. So even dot take 10. So this is my RDD. Okay. So what we did was we removed those elements. We did not multiply. We basically kept only the elements which has this. Now let me just try to do something here. Imagine that you only wanted to retain the lines. Let's say you want to here. What do you want to do? We want to convert all of this into upper caps. Okay. So let me first note it in the notebook. So we are saying what was that function? Where lines equals. If you have to convert it into say if we have to convert it into upper caps, right? What we will do? We will first load it like this. Okay. Then we have to define a function to upper. Okay. And here it takes a string and returns a string, correct? And we're defining this method. And here we're just returning two uppercase. All right. That's what we are doing. So we could say lines dot map, and I'm calling my method called toUp. It returns another RDD. Okay, so let's see if it works, and we could take a look at that. Okay, we could actually make it extremely simple also. We could just we could just do this. All right, so let me just show you this part. So we are defining okay, so we just define the same RDD again, and let's just test if it is working. Okay, so it seems to be working. Now let's try to convert it into uppercase. So we defined our method called toUp. toUp, what it does, it takes anything from you and convert that into uppercase. So it is working. Now the next thing we want to do is we are calling that function toUp using map on top of our RDD called lines. Now let's take a look at this new RDD. This is basically another RDD, and this RDD you could say just take 10, take a look at 10 elements. They have been converted into the uppercase. Okay, so now the next thing I would like to do is I want to just retain the one that has having you. Okay, so lines dot filter, and I could define a function contains EU. Okay, this is the function I want to define, that it takes a string and returns Boolean. Okay, and here what it says s dot let me just test if there is a method called where is, let's say, the you are here, right? You are here, correct? So here we could say contains and you, does it work? Yes, so there is a method called contains in Scala string. So we could just use that and say s dot contains you. Okay, so this method just checks whether a particular string contains you or not. We can basically try running it. Okay, we can try running this function. We can say contains you, and here let's say we are passing this string. We're passing this string and checking whether it contains you or not. Okay, so it says too many arguments. Okay, we don't have to pass the second argument. Yes. Okay, if we don't pass you here, it says false. That means the function is working. Now we can say lines, up lines, as in uppercase lines dot filter and contains you. All right. So these are the lines having you. So let's take a look at that by using take 10 or maybe 20. So you can see it has printed all the lines that contains a keyword called you. Okay, here there is your country, then there is your specific. Anywhere it has found you, it has printed that. Okay, in each line it has done that. So it basically it has done the filtering based on the lines. Okay, so you could try executing it by yourself. So we just wrote a program that would convert the text into uppercase as well as give you all the lines that contain a specific keyword. Okay, so you can kind of write graph, a distributed graph using this filter method. Yes, go ahead, somebody unmuted. Okay, a question from Mohammed is, can you have regular expression? Of course. So here, whatever function do you like to do, whatever complex logic you want to write in Scala, you can write that complex logic, whether it's regular expression, whether it's writing your own complex strategy or something, whatever can be done, Scala can be done inside contains you. All right, that's one advantage why Spark won over the frameworks like Pig. Pig was constrained by the language. Here, there is no constraint because whatever Scala can do, these individual filter methods, map methods, and flatMap methods, all of these transformations and actions can do all of that. So it's basically powered by the same flexibility as Scala does. And Scala can do everything which Scala provides, plus what Java can provide. So essentially, with this kind of mechanism, you can do almost everything. You can convert almost every kind of program into Spark. All right. So we were able to write something that wasn't there in this. A question from Hitendra is, take method gives you first n elements. Is there a way to get a specific one? Right? No, there is no straight way to get that. Let's say you are looking for a particular line having some value. then you can use the filter method. Okay. All right. So these were a quick overview of transformations. Now let's take a look at the other things called actions. So transformations create another RDD on which you can apply other functions, right? While operations like the RDD provides something called actions. The other kind of operations the RDD provides you is called actions. Now actions are basically something that cause the full execution of transformations, and it involves both Spark driver as well as the nodes. Okay, so action, like the way we did take, what it did was it actually did the full execution, while transformations are not executed immediately. The filter, the map, it does not get executed immediately. You must have noticed by now that when we execute the transformations, it doesn't do anything. It just takes the argument, just checks whether the code was correct, and that's all. Let me show you this. All of this doesn't do anything at all. It just makes note of it and be happy there. It doesn't do anything. Okay? So the actual processing starts when you call an action here, when you say having you dot take, only then things are happening. So take is an action. So Spark has been lazily waiting for your orders that when will you pass an action, only then it did the execution. Till that point of time, it just kept on making notes. It just kept on making notes. So now let me, so it involves both Spark driver as well as nodes. And so example is take brings back the data from to the driver from the RDD. So take is, so while on one hand sc.text file converts a text file into an RDD, the take brings back the data from RDD to local values. Right? So here is an example of take. Though we have been using take for quite some time, this would be very clear to all of you. So this is what the take looks like. Okay, so we say take 5, it basically brings first 5 elements back to you. A question from Bhati Raja is that looks like the same feature we have in Pig. That's right. So this design of lazy evaluation comes from Pig, just that Pig was a separate language itself called Pig Latin. Now, Pig Latin has its own constraints because it wasn't as flexible as the Scala is, or as the Spark's way of construction is, that you can basically Spark extended the idea of Pig combined with the concepts from MapReduce, and that's where this powerful mechanism of transformations and actions have come into place. So we can also use another action called saveAsTextFile. The output of anything can be saved back to the HDFS using saveAsTextFile. So saveAsTextFile takes a directory as argument and then saves the results into the HDFS. Okay, if you give the line, if you give the file name or folder name starting with slash, that means it's an absolute path. Otherwise, it's a relative path. All right. So I'll show you this. Okay. So let's say here, the code that we were writing, let's say we want to save it in HDFS. So we say save as text file, and I say having you, okay, you say, or I'll just say a better word, grep you. Okay, that's the grep. Okay, and this is the name of the folder. So let me just try to execute this, and save as text is also an action. That's right. Now, if you go to home directory, you will see that grep will be a folder in which there will be files which take. Okay, so there'll be folder in which we have two parts. Since our data by default had two partitions, the input that is being read was having two partitions. For some reason, Spark decided to keep it two partitions. So therefore, the output is also having two partitions. Okay, so it has basically given only the lines in the uppercase which have YOU. All right. Also, we could do exactly same thing with Python. Okay, if you wanted to use it in Python, you could just say def this, and we could say s, and how do you write uppercase in Scala? So you can actually do exactly same thing by just translating this logic by removing these extra keywords in Python. Okay, you can actually do the same thing, exactly same thing using Python. All right, so those who want to execute this, yes. So all right, so this is another example of action. So action essentially saves the data in a directory. If the directory already exists, it is going to throw an error, so be aware. Next is okay, so here we are trying to demonstrate the saveAsTextFile. Okay, next. Now, what we just learned was that there is something called transformation and something called action. The examples of transformation was map, action was take. A transformation generally returns an RDD, while an action returns a local value. Okay, action generally brings back the data to you or save it in the disk, right? So action basically executes immediately and gets everything done, while transformation, when you execute transformation like map, filter, it doesn't do things immediately. Instead, it waits for you to call an action. All right, easier way to understand it is this way, that imagine that you are in a restaurant, and there is a waiter, right? And let's say a person says, give me a cheeseburger, soup, and a plate of noodles. And there is another person who says, give me a soup and a plate of noodles for me. So here the waiter is patiently or sometimes lazily waiting for your orders. And then once you say go ahead, then it basically the waiter optimizes the optimizes the orders. Similarly, he can go to the kitchen and chef can further optimize things, because there could be other people who wanted the similar orders. So with the lazy evaluation, a lot of optimization is possible, right? Like for example, if we do two maps, then those two maps will be combined together, right? So similarly, the waiter has this ability here, because waiter has taken all the orders in the notebook and is able to see that, okay, so soup can be combined together, and plate of noodles can be combined, and the burger is the extra one. So that way the cook will be able to optimize, as well as this waiter has also saved multiple trips to the kitchen. Okay, so imagine that there was an instant waiter who was really fast. The moment you utter an order, he runs to the kitchen and places your order and waits there to get your results, get your orders, right? This is called instant evaluation. So the moment you said cheeseburger, the waiter runs to the kitchen to get it, and then if you are asking for soup, you'll have to wait until the waiter finishes the first order. Okay, so basically this is called instant evaluation. So these are the two different mm, waiters. One is instant and other is lazy. What kind of waiter do you generally prefer, the lazy one or the instant one? Okay, all right, Mohammed prefers a instant one. Okay, anybody? All right, but I personally prefer the lazy one. Okay, because he takes the orders patiently and brings them back together, right? All right, all right. So good, good. It depends on the requirement, right? When you are a single and you just want to grab a burger and run, then you would probably like to have an instant order kind of model. If you are with friends, you would like to wait and you want to get the orders together, right? Yeah, that's right. Thank you, Binta, Sachin, and right. Now, a question to all of you. The usual programming language like Python or Scala, is it instant or is it lazy? That's right. It is instant. While the frameworks like Pig, TensorFlow, Spark, they are lazy in the sense that we have to explicitly execute things later on. And while we are executing the statement, they are basically making notes of it. All right. The usual programming languages have instant evaluation. And as you type where x equals 2 plus 10, the value of x will not have 2 and plus and 10. It will have 12. Okay. So every time we call an action, entire RDD must be computed from the scratch. Every time in the below statement, every time the statement D is executed, A, B, and C would run. Now here, take a look at this one. Here you can see this code is in Python. So the reason why we have kept it, this one has less keywords, so it looks neater. So here you can see that there's lines. Few lines is after lines.filter. Uppercase lines is after few lines.map and two uppercase. So when we call this uppercase lines.count, it needs to evaluate this, which needs to evaluate this, which needs to evaluate this, and which needs to load the data from here, right? So all of these will be executed when we execute, all of these A, B, and C will be executed when we run D, okay? All right. So when we call a transformation, it is not evaluated immediately. When we call a transformation, It is not evaluated immediately. It helps Spark optimize the performance similar to Pig, TensorFlow, etc. Instead of thinking of RDD as a data set, think of it as instruction on how to compute data. Let me take a look. Let me show you here a good example. So imagine that you have two map function, map1 and map2, which are being executed here. And then we are collecting, right? So this will be optimized because it knows that when you call collect, it knows the graph. So it has the luxury of optimizing your methods. It would combine x.trim and uppercase into a single method and execute. It doesn't happen at coding level. I'm just showing it on the code level, just to give you an idea, a picture that how does it look like, but it would be happening more on execution level. All right. So now, so Spark, while we are giving it commands, when we are asking it to execute transformations, what it is doing is it is creating a lineage graph. Lineage graph is also called DAG, directed acyclic graph. Okay, directed acyclic graph, the word is too big, but humans inherently get it. Directed acyclic graph is nothing but a dependency graph in which we have the task A, task B, task C. Task C depends on B or A. So we kind of create that dependency graph, and we do it all the time. So on the right hand side, you see the lineage graph. On the left hand side, I'm showing the code. So on the left hand side, we are saying lines equals sc.textfile. Of course, there will be where lines and for Scala. And on the right hand side, you see that here it's creating lines as one of the node. And then the arrow represents the operation, like it's a text file. Then we say filter. Then it again creates another node called few lines, which is basically filter on top of the lines. Then we have uppercase lines, which is nothing but map on top of few lines. Then lowercase lines, which is basically map again on the top of few lines. And when we say uppercase lines dot count, it would basically execute the whole graph and call the counts. Okay, so the moment we call this one, it will execute step 1, 2, and then this one. Okay, so essentially the code that we are calling internally, the moment we are calling map or anything internally, it's basically making a node of what you want to execute by the way of a graph. All right, to convert one record of an RDD into multiple records, we could use further transformations such as flatMap. So this was about lineage graph. I want to go ahead with more transformations. We need to learn more transformations. Only then we will be able to convert our business problems into something that can be distributed. All right, it's all about, the whole thing is all about using multiple computers to do the computing. All right, so to convert one record of RDD into multiple record, we use flatMap exactly like Scala. So if let's say we want to convert this array. This is a dog named Jerry. It has two strings. One, this is a dog. Second is named Jerry. We want to convert that into a single array. Here we defined two words function, which splits that each line. We've already done this once. Then we are saying words RDD equals lines RDD dot flatMap, and then calling that function. And at the end, we are calling collect. When we call collect, the action is called, and then all of this will be executed, and the result will be this. So flatMap basically calls the argument, whatever method we are calling here, this function will be called on every element of this RDD. Whatever is the result of two words after execution of two words on this, whatever is the outcome, it creates a single array out of those arrays, right? So let's say you can see in the diagram. So two words is called. So this is a dog will be converted into one array of strings, and two words will be again converted into other strings. So the resultant will be a single array containing all the elements. Now, question is, how is it different from map? Question is, how is it different from map? This question actually you asked in the when we were discussing Scala also. So in the case of map, the resulting RDD and input RDD have same number of elements, right? When we call, so map as well as flatMap both run your function against every element in RDD. Just that in case of flatMap, whatever in case of flatMap, the function should return an array instead of single value. In case of map, it should just return another object. So in case of map, the output elements are equal to the input elements, while in case of flatMap, the output elements, number of elements could be different. It could be less, it could be more from the source elements. Okay, so map can only convert one to one, while flatMap could convert one to many. Okay, what if we used map instead of flatMap in previous example? So what would have happened is this. So we would still get two elements, first element containing one array, other element containing another array. Okay, so flatMap is very similar to Hadoop's map. flatMap is very similar to Hadoop's map, in which flatMap can also give 0 or more elements. Flatmap can also give 0 elements, which means that those elements will be deleted. While in case of map, we can never delete the elements, right? So flatmap can emulate filter as well as the normal map. All right. So flatmap can emulate filter. It can produce it can produce many values as well as no value, which empty array, which basically it could just return empty. That means it wants to drop those elements. So using flatmap, you can emulate both filter and map. So if it gives out a single value, it behaves like map. If it gives out empty, it behaves like filter. Yes, that's right, Hitendra. I'm talking about Hadoop's map from MapReduce framework. All right. So here I'm trying to demonstrate how to use flatmap as map. That should be pretty simple for all of you. Imagine that we have multiplied by 2 function. The only difference is that this function is returning an array having a single element. This function is returning an array of single element. Okay. All right. So here, basically this is behaving like your usual map. Okay. So using flatmap, you could do that. Okay. So don't execute, if you are copying pasting this, don't copy paste these lines because that is representing the output. Okay. So let's execute this. All right. Now let's run this. Okay. So dbls dot take 10, you can see it has doubled the elements. Great. So basically, you can use flatMap as map. Similarly, you can use the flatMap as filter. Say you define a function called isEven. If this is the value is divisible by 2, then it returns an array of single element. Otherwise, it returns an array of empty. It returns an array of 0 elements. So in that case, this isEven is returning an array, either empty array or array with a single element. Then we can use the flatMap to filter the elements. So this is how we could use the flatMap as filter. I could show you this. Okay. And so you can see that. So the answer was 2, 4, and 6. All right, because we just got the 3 elements.
So Sandeep, the difference is a flat map returns an array, and
That's right.
and the map which we are showing, it returns all the element equal to the elements which you have given in the input.
Correct.
Okay. So what do you mean by array with one element? Because I see that there are 4 or 5 elements. What do you mean by?
Do you see this here?
Yeah.
Inside isEven function is returning what? A single element.
Okay. But if we do the uppercase, then?
In the uppercase, if you want to do the uppercase, right? In that case, we'll return the whole line with the uppercase.
Okay, as a single element.
Single element, yeah.
Okay.
Okay. All right. So flatMap, essentially the function that we are passing to flatMap must return an array, and it basically gathers all that. Now, there are more transformations such as union, and we are going to talk about more transformations in the next session, which will be tomorrow. So we would like to finish the transformations and actions part tomorrow, and then move on to the other concepts in Spark. All right. So that's pretty much for today. If you have Mohammed, today it'll be very difficult for me because I have a hard stop today. I would love to answer your question maybe tomorrow after the session. If you have more questions, please drop me an email. If you have questions related to something that I can answer in a couple of minutes, I would love to answer now. All right. So I have a bit of hard stop today. We can continue the discussion maybe tomorrow if that's okay. All right, great, wonderful. So all right, so I look forward to seeing you tomorrow at the same time, and we will continue learning how to solve problems with Spark. Okay, so we're going to dive deep into more concepts in Spark, and then we will work on more problems. That then will make more sense. Question from David is, where is the Unix file for the output? The file that is being created is in the HDFS. Okay, if you want to specify the local files, then we'll have to say file : // Okay. All right, we were opening the file in the hue. Hue generally shows, hue is basically for the file system on the HDFS. All right, great, wonderful set of questions. I look forward to see you next tomorrow at the same time. Bye bye. Have a good day.